All right, so for 10.2, we're going to look at some further applications of like our trig function. So like sine, cosine, stuff like that. So we're going to look at when we're given a triangle. We're going to be given a few things like a degree or a side length, and we're going to use that to find the sides lengths that we have, and which is just going to be one. It's just going to be labeled like X or something. It's just going to be left out. And then we're also going to look at finding angle measures, which that pretty much is kind of like the opposite of what we do for finding the side length. So we're going to use what we know about our trig functions, which we just went over. And we're going to use that and apply it to these situations so that we can find some side lengths and some angle measures. So this process won't be too complicated, but you're just going to have to make sure that you're on top of your sine, cosine, and tangent functions, which, as I told you before, the best way to remember that is to, and you could always just write this down. So, SOHCAHTOA. So if we use SOHCAHTOA, that tells you what sine is. So sine is opposite over hypotenuse, cosine is adjacent over a hypotenuse, and then tangent is opposite over adjacent. So for the first part of this, we're looking for the value of x. So if we just look at number 1, you can see that x is here and it's left out. That's just saying that the measure of this length, this side length, is x, and we want to know what that is. So it's pretty straightforward. You just have to make sure to get your trig functions correct. So if you see here, we're given 64 degrees. So we're going to use that 64 degrees, and we're going to figure out, is this x opposite of that 64? Is it adjacent? Is it the hypotenuse? We're going to look at x and 25 and use 64 to help us figure that out. So if we start at 64 and we go opposite, that is what x is. And then we're also given, so x is opposite, so that tells us that we're either going to be using sine or tangent. We're not going to be using cosine for number 1. Then we can look at 25 and say, okay, is 25 an adjacent side to 64, or is it the hypotenuse? And if we start at this 90-degree angle and go opposite, we would know that 25 is the hypotenuse. So here's how you set this up. We know we're using sine because we have opposite and hypotenuse. So we are going to use this angle, and we're going to plug that in for sine, or I guess with sine. So before, we didn't have 64, we had theta, and we used theta to figure out like what x and 25 was. But now we're going to actually use a measure or a degree and figure that out. So we've got sine 64 equal to x over 25. And the reason it's x over 25 is because that's just opposite over hypotenuse. So that's pretty much the steps to doing every single one of these angle or side length problems. So you're going to start with your angle, and you're going to figure out, do I have opposite and hypotenuse? Do I have adjacent hypotenuse? Or do I have opposite and adjacent? Because that tells you which trig function to use. And then you take your angle measure and plug that in with sine, cosine, or tangent, and then set it equal to whatever your trig ratio is. So for instance, on this one, it was sine. So we're saying opposite, which is x, over hypotenuse, which is 25. So now we just have to solve for x here. So we can do that anytime we have a fraction and we want to get rid of the denominator. We just multiply on both sides. So we're going to say times 25 to both sides. So that's going to get rid of it. And we'll have 25 times sine 64 equal to x, which you can put this in parentheses if you want, but you don't have to. All right, so for this part, you just have to plug that in your calculator. So your calculator has a sine, cosine, and tangent function, or it should. If it doesn't, just let me know and I'll help you out a little bit. I may give you like a good calculator to use on your phone. But all you have to do is plug in 25 in front of, or plug in 25 first and then press sine, plug in 64, it ends your parentheses, and you'll get your answer. And we can just round these up to the nearest, like the first decimal place. That's fine with me. So this would be x is equal to 22.5. All right, so I'll do another one. I'll probably do one of each, like sine, tangent, and cosine, or sine, cosine, and tangent. But for number one on the notes, we've got x is equal to 22.5. And actually, let me move this. I'll move it over here, even though you may not be able to see it. X is equal to 22.5. All right, so number two. We have a side length left out, which is x here, and we need to know what that x is. So the first thing you're going to do is go to your angle measure that they give you. So they give us 47 degrees. Now we want to know, is that x, is x and 12, which are what we're given, are those like opposite and hypotenuse, adjacent hypotenuse, or opposite and adjacent to this 47 degree angle? So 47 degrees, if we go opposite of that, that would be x. So we know we've got, if we go back over to SOHCAHTOA, we know we've got opposite, so we're not going to deal with cosine here. We're either looking at sine, which is opposite and hypotenuse, or opposite and adjacent. So then we can go to 12 and say, okay, is 12 adjacent to 47 degrees, or is it the hypotenuse of this triangle? And you could either look at this and know that it's adjacent to 47 degrees, or you can say, okay, I know that my hypotenuse has to be opposite of my 90-degree angle. So if I go over here, this would be my hypotenuse, which that's not 12. So that means that this 12 has to be adjacent. So we're going to use tangent. We're using opposite over adjacent. So we're going to be saying tan 47 equal to opposite, which was x, over adjacent, which was 12. And then we're going to, since we have on the right side x over 12, we need to solve for x. X is divided by 12, so the opposite of dividing by 12 would be multiplying by 12. So we're going to multiply 12 on both sides, which will cancel it out on the right. Then we'll get 12 times tangent, or you could just write 12 in front of tangent. It's the same thing. So then we'll have 47 equal to x, and then you plug this portion into your calculator. So we would plug in 12, press our tangent button, 47, and that's going to be equal to x equal to, let's see, 12.9. So it's pretty simple once you get down the method here. And actually, I'm going to, well, I'll do a couple of these because I can't just do one of each because they actually change a little bit. But it's okay. I think after I show you one of them, it'll be okay. All right, so that is sine and tangent. We'll do one with cosine next. So if we look at number 3, we've got 18 degrees here. So we're going to use that to figure out if x and 34, what trig function would go with x and 34. So if we start at 18, which is actually, the degree is right here, the angle's right there. If we go opposite, we don't have anything there. So we know that we're not dealing with opposite and hypotenuse, so we're not dealing with sine, and we're not dealing with opposite and adjacent, so we're not dealing with tangent. So you could already determine that this is going to be cosine. So we're going to say cosine of 18 is equal to, and cosine is adjacent over hypotenuse. So we need to know the adjacent side here, which it would be x. And then the hypotenuse here would be 34 because 34 is opposite of this 90-degree angle, so that's the hypotenuse. So it'd be x over 34. And then we are going to multiply 34 on both sides to get rid of it on the right, to get x by itself. 34. So then we'll have 34 cosine 18 is equal to x. So then x will equal 32.3. So all you have to do is plug this portion in your calculator. Like I said, you just got to make sure that you get your trig function right, and then everything else is really just plugging it in. Kind of like we did before, except now instead of theta, we have an actual measure for that angle. Now that worked out, those three problems worked out for us nicely because we had 34 or like 25 and 12 as our denominator. Some of these you're going to have x as the denominator, so I'll show you how to deal with that. So let's look at number 4. Let me get rid of this. Get out of here. Okay. So if we look at number 4, we're going to take the same process. We're going to start with our angle. So we're given 35 degrees, and we want to know x and 9. What do those tell us about our trig functions? So if we use 35 and go opposite, we have 9. And then this x would actually be adjacent because this x couldn't be our hypotenuse because the hypotenuse is always opposite of this 90-degree angle. So here we've got adjacent and opposite, or opposite and adjacent. So that tells us to use tangent. So we're going to say tangent of our angle, which is 35 degrees, is equal to, now we're going to say opposite over adjacent. So the opposite would be 9. And the adjacent would be x. So now you see here, we've actually got x on the bottom of our fraction, but we're going to get rid of it the same way, except we're just going to have to take an extra step. So if we're looking at this, we want to get x out from under this fraction. So the way that we would do that is by multiplying it on both sides. So then we're going to end up with x times tangent of 35 is equal to 9. Now, the thing or the operation that is happening here and here between these two terms is multiplication. So if we want to get x by itself, we're just going to divide both sides by tangent of 35, which is going to give me x is equal to 9 divided by tangent 35. And then you just plug this portion into your calculator. So you can see we had to take the extra step of dividing to get x by itself after we multiplied in the first step. So this, when you have a problem that ends up like this, it's just a little bit more complicated, but it's still not too bad. So let me plug this in my calculator. So we've got 9 divided by tangent 35. The only thing you have to watch for here is just make sure you plug it in correctly, and you should be okay. So x is equal to 12.9. And I'll do another one of those just so you can see it again. So number 5, we've got our angle here is 63, and then we've got x and 27. We want to know what x and 27 will tell us as far as our trig function, which one to use. So if we use 63 and go opposite of that, we've got 27. And then x here is opposite of our 90-degree angle, so that is our hypotenuse. So here we've got opposite and hypotenuse, which tells us sine, which you could go back to SOHCAHTOA and see that here. So we're going to use sine and then plug in 63 with that, which is just the measure of our angle. And then we're going to say, okay, opposite, which was 27, over hypotenuse, which was x. So this is our setup now. Sine 63 is equal to 27 over x. And then we are going to plug in, or then we're going to solve for x. So the first thing we have to do is get rid of this x on the bottom of our fraction. So if we want to do that, since it's dividing here, any fraction is dividing, the opposite of that would be multiplying. So we're going to multiply by x on both sides to get x sine 63 equal to 27. And now we have x times this sine of 63. So if we want to get x by itself, we have to divide sine 63 on both sides. And that will get rid of it on the left. And we'll be left with x is equal to 27 sine 63. So then that's going to tell us that x, after we plug this in, x is equal to 30.3. So that is looking at finding a side length when you are given an angle measure and another side length, and then you have a side length left out. So the process is figure out which trig function you use. So if you have opposite and hypotenuse, you're going to use sine. If you have adjacent and hypotenuse, you're going to use cosine. And then if you have opposite and adjacent, you're going to use tangent. And then you plug in your angle with whatever trig function you have, and then you set up your ratio and then solve for the variable that's left out. All right, so then we can also find the angle measure when we're given two side lengths. So here's how this works. So if you know sine, cosine, tangent, the ratio, which is just our two side lengths, you can use the inverse ratio, which is sine of -1, cosine -1, tangent -1, to find the angle measure. So if sine of theta is equal to x, then theta is equal to, which is just the angle, is equal to sine, or the inverse sine of x. If cosine of theta is equal to x, then our angle, which is theta, is equal to cosine, the inverse cosine of x. And then last, we've got if tangent of theta is equal to x, then our angle, which is theta, is equal to tangent, the inverse tangent of x. So that's a little weird, which we use our calculator for this too. But I'll show you, it's not too bad. This is actually a little bit easier. So we're going to find the missing angle. So the missing angle is always theta, and we're going to figure out what that angle measure actually is. So if we look at number 7, we've just got to figure out first, what's our trig ratio? So do we have opposite hypotenuse? Do we have adjacent hypotenuse, or opposite and adjacent? Because that's going to tell us our trig function. So we're going to use this angle, theta, that we're given, and we're going to look at our angle measures and see what we have here. So if we go opposite of that, we've got 8. So we know we have an opposite. And then if we go adjacent to that, we have 14, which if you want to test that, you could just say, okay, I know my hypotenuse is opposite of my 90-degree angle, so that can't be the hypotenuse, so it has to be adjacent. So right now I have tangent theta is equal to opposite over adjacent, which is 8/4. So you just have to make sure you get this trig function part right, and then you just plug in theta with that trig function, because technically tan of theta, or tangent of theta, is equal to 8/4 here. That's just our trig function, our trig ratio rules. So you just have to make sure you get that right. And we had opposite and adjacent, so that tells you to use tangent here. That's how we figure that out. So then all we have to do now is just do the inverse. So we would say, okay, we know that tangent of theta is equal to x, which x here would be 8/14. So now we're just going to say, okay, theta is equal to inverse tangent of 8/14. And then you would plug that in your calculator, which it is second. On mine, it's second tangent. Up above it, I have like a little tan -1. And then you would just plug in 8 over 14, and you would get 29.7 degrees. So all of these answers will be in degrees because we're looking for angle measures. So I'll do that again because I know it's probably a little weird. But it's really, once you figure out, I think the hardest part is figuring out what trig function you have. That's the hardest thing for people to get down. But like I said, just use your angle, which here it's not an angle measure, it's actually just theta. We're going to use that and decide, do we have opposite, hypotenuse, adjacent, hypotenuse, or opposite and adjacent? Because that just tells you, if you use SOHCAHTOA, that tells you your trig function pretty easily. So if we look at number 8, we're going to do the same thing. We're going to start at this angle here, which is theta, and we're actually going to find that after we set this up. So we want to know which trig function we use. So with theta, is 40 and 38, is that opposite, adjacent, or what is it? So if we go opposite of this, we don't have anything there. So that means that we could already probably figure out this was cosine, but I'll just take you through the steps anyway. So we know that we don't have opposite here. We don't have an opposite side. So we either have, we only have adjacent hypotenuse, but we'll go through it. So this angle, or this side that's opposite of 90 degrees, is the hypotenuse. So we know we have a hypotenuse here. And since this side here was the opposite, then the only thing that we can have left is adjacent. So we know that we have cosine of theta here, because that angle measure there is theta, and it goes with cosine, or our trig function. Cosine of theta here is going to be equal to adjacent 38 over hypotenuse, which is 40. So that is our trig ratio. Now, if we want to find that angle measure, all we have to do is go back here and use this part. We would just say that theta is going to be equal to inverse cosine of whatever this trig ratio is. So it'll be of 38 over 40, and we'll plug that in our calculator. And we'll get x is equal to 18.2 degrees. So finding the angle measures, after you identify which trig function you have, it's really easy. You're really just saying the cosine of theta, or the tangent of theta, whatever it is, your trig function of theta is equal to that trig ratio. And then you just set up the inverse cosine, or inverse tangent, or inverse sine of whatever that trig ratio is, and then that tells you what your degrees are. So we're not going to worry about doing the angle of elevation and angle of depression. We're not going to worry about all that. We're just going to get all this, like these basic skills down. So that's it for this video. Make sure that if you've got any questions, you let me know. And I'll talk to you in the next